Now you may think that you've got this similar triangle stuff down, and you probably do at this point. It's really not that difficult. But this exercise is really important because what I want you to notice is that the triangle on the left side is going to mimic a triangle, a right triangle that's constructed on a unit circle. And that's the important thing. So what I'm doing here is I've got a triangle here on this left side. Let's grab the pen here. So this triangle right here represents a triangle that has a hypotenuse length over here of 1 unit. Okay, let's erase that. We don't need that anymore, but the idea is that triangle would be just like any other triangle that's placed on the unit circle. Okay, and that's what we're going to be using from here on out in the course. Okay, so this is an important problem. Again, let's go ahead and figure out how to solve for this side over here that we don't know. Now, in the last couple triangles, we were given this side. Oops, we were given this side over here. Okay, in this case, we're not. So there's a couple approaches that we can use to solve for that, and you can really use whichever one you want. What I do know is I can find this side right here, and I know I can find that side because this is a right triangle. Okay, so I've got 1/2 squared, which is this side, plus that question mark. Let's call it something besides question mark. Let's call it x. Okay, plus x squared. It's got to be equal to 1 squared. So if I take 1/2 and I square that, I get a 4th. I've got x squared is equal to 1. Subtract a 4th from both sides, gives me x squared is equal to 3/4. And now we'll take the square root of both sides. So we're going to get plus or minus the square root of 3 over 2. Maybe I skipped one too many steps there for you. So how did I get that? Let's do it over here. So the square root of 3/4. I don't like the way that's written. Let's erase that. Okay, let's try it again. So the square root, much better, of 3/4 is the same thing as the square root of 3 over the square root of 4. And of course the square root of 3 is just the square root of 3. We can't reduce that any more than it already is, and the square root of 4 is 2. Again, we got plus or minus because we took the square root of both sides. However, in this case, we're dealing with a length value. So I'm going to use the positive portion of this. So this length side right here in the green is going to be, so x is equal to square root of 3 over 2. Now, what do we multiply to go from one triangle to another? So to go from the left triangle to the right triangle, looks like I'm multiplying by 6. Okay, so let's do that here. If we multiply by 6, we'll find out this missing length over here. So I've got square root of 3 over 2 multiplied by 6, which, if we want to, we can write that as 6 over 1. We don't need a common denominator because we're multiplying fractions. So we've got the square root, well, let's just go ahead and simplify this first. I've got 6 divided by 2 is 3. So I've got 3 square roots of 3. This is the answer that you leave it at. You don't change it all. That's an exact value. Okay, so don't give me a decimal version on your calculator. This is what I'm looking for. Another way that you could have set this up is you could have said this. You could have said that, could have called this, I don't know, we'll give it a variable name. Let's call it b. Okay, so b is what we're looking for here. So we could have said, well, square root of 3 over 2 divided by b is equal to 1/2 divided by 3. So this divided by this is equal to this divided by this. Then, of course, if we do our cross multiplication, okay, we get 3 square roots of 3 over 2 is equal to b over 2. Multiply both sides by 2, and you get 3 square roots of 3 is equal to b. So the same exact value.